It is not permissible to backfeed a main lug panel with a 100 amp breaker and then use the existing main lugs to feed a subpanel. This practice presents several significant concerns. Firstly, there is a considerable safety hazard. Backfeeding can create an electrical hazard if the main breaker is accidentally opened. This could result in power being fed back into the utility grid, potentially causing injury or equipment damage. Secondly, it constitutes a code violation. The National Electrical Code, NEC, specifically prohibits backfeeding of main overcurrent devices, breakers or fuses, as stated in Article 408.16 F. Thirdly, there is a risk of overloading. Backfeeding the main lug panel with a 100 amp breaker and using the main lugs to feed a subpanel could overload the main breaker and create a fire hazard. Fourthly, the electrical stability of the system may be compromised due to the potential for voltage fluctuations and imbalances. Instead of backfeeding the main lug panel, consider alternative solutions to achieve the desired outcome. One alternative is to install a separate feeder. Run a dedicated feeder from the main service panel to the subpanel. This provides a safe and code-compliant method to supply power to the subpanel. Another alternative is to use a transfer switch. Install a transfer switch between the main service panel and the subpanel. This allows for the subpanel to be powered from a backup generator or other alternate source in the event of a power outage. The NEC provides specific guidelines for sizing conductors. Section 310.13 outlines the requirements for ampacity, which is the current carrying capacity of a conductor. When selecting conductors for feeders and branch circuits, you must ensure that they are adequately sized to handle the anticipated load. Voltage drop is also an important consideration. Excessive voltage drop can lead to equipment malfunction and inefficiency. NEC Article 215.2 provides guidelines for minimizing voltage drop in feeder circuits. It is generally recommended to limit voltage drop to no more than 3% in branch circuits and 5% in feeders. Grounding is another crucial aspect of electrical safety. A properly grounded system provides a low impedance path for fault current, which helps to protect against electric shock. NEC Article 250 provides detailed requirements for grounding and bonding. Grounding electrode systems should be installed in accordance with NEC requirements to ensure effective grounding. Bonding is the process of connecting metallic parts of an electrical system together to create a low impedance path for fault current. NEC Article 250 provides requirements for bonding electrical equipment and enclosures. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when a fault occurs, preventing damage to equipment and reducing the risk of fire. Circuit breakers are resettable overcurrent protection devices that can be manually or automatically reset after a fault has been cleared. Fuses are non-resettable overcurrent protection devices that must be replaced after they have blown. Arc fault circuit interrupters of size are designed to protect against arc faults, which are dangerous electrical conditions that can cause fires. A size detect arc faults and interrupt the flow of current, preventing the arc fault from escalating into a fire. Ground fault circuit interrupters, GFCIs, are designed to protect against ground faults, which occur when current leaks to ground. GFCIs detect ground faults and interrupt the flow of current, preventing electric shock. Surge protective devices, SPDs, are designed to protect electrical equipment from voltage surges, which are temporary increases in voltage that can damage sensitive electronics. SPD diverts surge current away from protected equipment, reducing the risk of damage. The electrical panels, also known as load centers, are enclosures that house circuit breakers or fuses and provide a central point for distributing electricity to various branch circuits. Electrical panels must be properly sized to accommodate the anticipated load and must be installed in accordance with the NEC requirements. Conduit is a protective raceway that is used to enclose electrical conductors. Conduit protects conductors from physical damage and provides a path for grounding. There are various types of conduit available, including rigid metal conduit, RMC, intermediate metal conduit, IMC, electrical metallic tubing, M, and flexible metal conduit. Wiring methods refer to the way in which electrical conductors are installed and supported. NEC Chapter 3 provides requirements for various wiring methods, including conduit, cable, and open wiring. Electrical boxes are enclosures that are used to terminate and protect electrical connections. Electrical boxes must be properly sized to accommodate the number of conductors and devices they contain. There are various types of electrical boxes available, including metal boxes, non-metallic boxes, and weatherproof boxes. Conductors are the wires that carry electrical current. Conductors must be properly sized to handle the anticipated load and must be insulated to prevent electrical shock. There are various types of conductors available, including copper conductors and aluminum conductors. Electrical tape is used to insulate and protect electrical connections. Electrical tape must be rated for the voltage and temperature of the application. Wire connectors are used to join electrical conductors together. Wire connectors must be properly sized for the number and size of conductors being joined. There are various types of wire connectors available, including twist-on connectors, push-in connectors, and crimp connectors. Electrical meters are used to measure the amount of electricity consumed. Electrical meters are typically installed by the utility company and are used to bill customers for their electricity usage. Transformers are used to step up or step down voltage levels. Transformers are commonly used to convert high voltage electricity from the utility grid to lower voltage electricity for use in homes and businesses. Generators are used to provide backup power in the event of a power outage. Generators can be powered by gasoline, diesel, or natural gas. Transfer switches are used to switch between utility power and generator power. A transfer switch ensures that the generator is properly isolated from the utility grid, preventing backfeeding. Uninterruptible power supplies, UPSs, are used to provide backup power to critical equipment in the event of a power outage. UPS typically use batteries to provide power for a short period of time, allowing equipment to be shut down safely. Lighting is an important aspect of electrical design. Proper lighting can improve visibility, safety, and productivity. There are various types of lighting available, including incandescent lighting, fluorescent lighting, LED lighting, and high-intensity discharge HID lighting. Electrical safety is of paramount importance. Always follow safe work practices when working with electricity. To energize circuits before working on them, use insulated tools, and wear appropriate personal protective equipment (PPE). If you are not qualified to perform electrical work, hire a licensed electrician. The NEC is a comprehensive set of standards for electrical installations. It is important to be familiar with the NEC requirements to ensure that electrical work is performed safely and in accordance with code. The NEC is updated every 3 years. Local jurisdictions may adopt and amend the NEC to meet their specific needs. It is important to check with your local authorities to determine which edition of the NEC is in effect. Electrical permits are required for many types of electrical work. Check with your local building department to determine whether a permit is required for your project. Electrical inspections are performed to ensure that electrical work is performed in accordance with the NEC and local codes. A licensed electrical inspector will inspect the work and issue a certificate of compliance if it meets the requirements. Electrical contractors are licensed professionals who are qualified to perform electrical work. When hiring an electrical contractor, be sure to check their license and insurance. Ask for references and get a written estimate before work begins. Electrical apprentices are individuals who are learning the electrical trade under the supervision of a licensed electrician. Apprentices must complete a certain number of hours of training and pass an exam to become licensed electricians. Electrical engineers are professionals who design and oversee the installation of electrical systems. Electrical engineers typically have a bachelor's degree in electrical engineering. They design power distribution systems, lighting systems, and control systems for buildings and industrial facilities. Backfeeding a main lug panel can damage sensitive electronic devices connected to the electrical system. The unstable voltage and current can cause premature failure or malfunction of appliances, computers, and other electronic equipment. Power quality refers to the stability and reliability of electrical power. Poor power quality can cause equipment malfunction, data loss, and other problems. Common power quality problems include voltage sags, voltage swells, and harmonic distortion. Power factor is a measure of how efficiently electrical power is being used. A low power factor can result in increased energy costs and reduced system capacity. Power factor correction can improve the efficiency of an electrical system and reduce energy costs. Electrical harmonics are unwanted frequencies that can distort the voltage and current waveforms. Harmonics can cause equipment overheating, increased energy losses, and other problems. Harmonic mitigation techniques can be used to reduce harmonic distortion in electrical systems. Electrical transients are short-duration voltage or current surges that can damage electrical equipment. Transients can be caused by lightning strikes, switching operations, or other events. Transient voltage surge suppressors, TVSSs, can be used to protect equipment from transients. Electromagnetic interference, EMI, is unwanted electrical noise that can interfere with the operation of electronic equipment. EMI can be caused by various sources, including radio transmitters, electrical equipment, and power lines. Shielding, filtering, and grounding can be used to reduce EMI. Static electricity is a buildup of electrical charge on a surface. Static electricity can damage sensitive electronic components and can cause fires in flammable environments. Grounding, humidity control, and anti-static materials can be used to control static electricity. Corrosion is the deterioration of metal due to chemical reactions. Corrosion can damage electrical equipment and reduce its lifespan. Protective coatings, cathodic protection, and corrosion inhibitors can be used to prevent corrosion. Vibration can damage electrical equipment and can cause connections to loosen. Vibration isolation techniques can be used to reduce vibration levels. Temperature can affect the performance and lifespan of electrical equipment. Overheating can cause equipment to fail prematurely. Proper ventilation and cooling can help to prevent overheating. Humidity can affect the performance and lifespan of electrical equipment. High humidity can cause corrosion and can reduce insulation resistance. Dehumidification and ventilation can help to control humidity. Altitude can affect the performance of electrical equipment. At high altitudes, the air is thinner, which can reduce the cooling capacity of equipment. Dirting factors must be applied to equipment operating at high altitudes. Dust and dirt can accumulate on electrical equipment and can cause overheating and reduce performance. Regular cleaning can help to prevent dust and dirt buildup. Rodents and insects can damage electrical equipment by chewing on wires and insulation. Sealing openings and using rodenticides and insecticides can help to prevent pests from entering electrical equipment. Labeling electrical equipment is important for safety and maintenance. Labels should identify the equipment, its voltage, and its function. Lockout-tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. Lockout-tagout procedures involve disconnecting the equipment from its power source and placing a lock and tag on the disconnecting device. Confined spaces are areas that are large enough for a person to enter and perform work, but have limited or restricted means of entry or exit and are not designed for continuous occupancy. Confined spaces can contain hazardous atmospheres such as oxygen deficiency, toxic gases, or flammable vapors. Special precautions must be taken when working in confined spaces. Electrical safety training is essential for all workers who work with or around electricity. Training should cover topics such as electrical hazards, safe work practices, and lockout-tagout procedures.